friends, my name is Kausalya Krishnamurthy. In today's episode, we are going to learn about digit sum rule, where to apply this and how to use this method. In a lot of competitive exams, you get questions where it involves a lot of calculation which could be time consuming. But using digit sum rule, you can possibly eliminate the wrong answers and also it helps you to check the possible answers. Digit sum rule can be applied without condition on multiplication, addition and subtraction, and it can be applied on division as well, but with certain conditions. Come, let us learn this in two different parts with some examples. In today's episode, we are going to discuss a topic called as digit sum, wherein imagine you got this question in a competitive exam. 1285,476 multiplied by 187. One way of solving this is obviously by multiplying the entire number. Here you got 4 options wherein you have to choose the right answer. If you multiply this, it is obviously time consuming. But in today's episode, we are going to use one method called digit sum, wherein you don't get the answer but you kind of check the right answer using the digit sum. So before that, I'll teach you how to use this method. What is digit sum? Digit sum is basically sum of all the digits in the given number. So I'll give you an example. Consider 1, 2, 7. So here 1 plus 2 is 3, 3 plus 7 is 10, and then 1 plus 0 is 1. So here digit sum is 1. And few people also call this as root digit. Now also observe here one more thing. 1, 2 and 7. Here 7 and 2 is 9. So you can discard that and you are left with 1. Whenever there is an operation which is performed on certain numbers, it could be addition, it could be subtraction or multiplication, then the same operation will be applied on its digit sum also. And it can be applied for division also, which we will discuss it later. Now let us take an example of multiplication and I will show you how it works. Let's say 11 into 12, which is 132, right? Now let's do the digit sum. What is 1 plus 1? 2. What is 1 plus 2? 3. And here 1 plus 3 is 4, 4 plus 2 is 6. So if you see, 2 into 3 is 6. Now you got option 1, 132, you check the digit sum and then you click the right answer as 132. Now imagine you had a second option where it was 123. So the unit sum is still the same, 6. But is it correct? No. Why? Because the multiplication of the unit digit should be 2, because 2 into 1. Here 3 is there. So this answer would have not been correct. Now you had option A, you checked option B. Imagine you had another option C which said 222. Here if you apply digit sum rule, 2 plus 2 is 2, 4, 4 plus 2 is 6. Will this be the correct answer? You don't know. Then you can also see 2 into 1, the multiplication of the unit digit numbers, that is also 2. What would you do? So this method is only a check for a possible answer. This does not give you the correct answer. So let's find out the digit sum here. 8 plus 1 is 9, so discard. 7 plus 2 is 9, so discard. 5 plus 4 is 9, discard. So we are left with 6. And out here 8 plus 1 is 9 and we are left with 7. So 6 into 7 is 42. So digit sum of this is 4 plus 2 is 6. So the digit sum of the product should also be 6. Now we have to find out the digit sum of all these 4 options and see which could be the possible answer. Here if you observe another thing, 6 into 7 is 42, which means the ending number of the product should be with 2. However, option D has 4. So this is not the right answer. Now we got 3 options. Let us see which one is the correct one. So here 8 plus 1 is 9, so discard. 3 plus 4 is 7, 7 plus 2 is 9, so discard. 0 is anyway 0, so not consider. 2 plus 4 is 6. Right? This could be a possible answer. Now, if you see option C, it has the similar number except for this place where we have 5, which means here you just have to add one more number, so this becomes 7. Out here, if you observe, there are similar numbers, but there is 3 added here and then 1 extra number added here, which means additional 4, which means it is 1 0 and then 1. So the correct answer for this particular question is option A. Now, is this method applicable on division? Yes, but no. So it's very tricky. So let's solve it with an example to understand better.